Welcome to multiple choice question 14 of the 2008 Mathematical Methods Exam 2. In this video, we will be looking at the solution for this question. A reminder that this video is in no way endorsed by VCAA. Now, before we move on, I just want to point out that the use of a CAS calculator is essential in answering this question. So for question 14, it says the minimum number of times that a fair coin can be tossed, so the probability of obtaining a head on each trial is less than 0.0005 is one of the following. So it's quite a lot to unpack, but the first thing that we can identify, because we're flipping a fair coin each time, is that the probability distribution that we're dealing with is going to be x is distributed as a binomial random variable, where the number of trials is n. We don't know how many trials, that's what we're asked to find, the minimum number of n. But the probability of success for a fair coin is 1/2. And next we want to interpret the probability statement in a symbolic form. So we want the probability that x is equal to n, so we get n heads from n tosses, to be less than 0.0005. From the symbolic form, we want to replace that with the formula for a binomial probability. So that is that we do n choose n heads, and the probability of obtaining a head is 1/2, so it's 1/2 to the power of n, and then we have 1 minus 1/2, which is also 1/2 to the power of 0 to represent that we get 0 tails, and we now want that to be less than 0.0005. And then if we simplify this before we use a calculator to help us answer this question, n choose n, that is 1, and 1/2 to the power of 0, or in fact anything to the power of 0 is simply 1. So on the left hand side we actually just have 1/2 to the power of n being less than 0.0005, and that's something the calculator can now help solve for us. On the CAS calculator, go into the main menu. Next we want to type in that simplified inequality that we want to solve on the calculator. So bringing up the keyboard, I'm going to put inside a set of brackets 1/2, and then we want that to be to the power of n, so variable n, and then we require that, using Math 3, to be less than 0.0005, and that's now something the calculator can solve, so we can go and highlight that and go interactive, equation inequality, solve for the variable n. And hitting OK will say that n must be greater than that exact value, but we can just change that to a decimal for this question. So looking at what the calculator gave, we have that n must be greater than 10.96 ... So the minimum number, if we go back to the question, the minimum number is that n must equal the first integer bigger than 10.96, which is 11. So that gives D being the correct answer to this problem. Now, before we finish up, I do want to show that you could trial and error this question. So as we identified, it's still a binomial distribution, and we want to obtain a head on every single trial. So that's a interactive distribution discrete binomial PDF, where we just want the total number of trials and the x value to be the same. So imagine we didn't know that it turned out to be 11, and you might just try 5 out of 5 with the probability of success being 0.5, and we could hit OK, and that probability is 0.03, so it's not less than 0.0005 yet. And then we could drag that line down, and you could test maybe 8 out of 8 trials, and then hitting OK, we get 0.0039, so we're getting closer. Then you might try 10 and 10, so that's 10 heads out of 10 trials, and hitting OK, that gives us 0.0009, so it's not quite less than what we require it to be, and we know that when we put 11 in here and 11 in here, we will get a number that's less than 0.0005, and from the calculator we can see that that's all checked out as we would require it. So for a question like that, you could have done the algebraic approach where we solved an inequality, or you could also have used that trial and error method where you just trial some different values and see which one leads to the correct answer. From the examiner's report, we can see that this question was done moderately well in the exam, with 60% of students getting the correct answer for this question. The 14% that selected C likely just rounded the wrong way and rounded down to 10 rather than up to 11, as was required by this question. And we could see from our trial and error method that if you put 10 in, you didn't have a probability that was less than 0.0005. You had to get to 11 as the minimum number of trials so that the probability was then less than the required value.